Let's take a look at a case where we are solving trigonometric equations and finding all solutions. So, example, find all solutions to sine theta equals 1/2. So for here, we can certainly start out with a unit circle and look at solutions first that happen between 0 and 2 pi. So sine of theta equals 1/2 here at pi over 6, and again at 5 pi over 6. And again, those are just the solutions that are occurring between 0 and 2 pi. But what about kind of every solution possible? Well, it can't be every real number because I know that there's a lot of angles, say like pi over 2, and sine of pi over 2 is not equal to 1/2. So how can I write out the angles that will make this true? So first, let's look at kind of each angle one at a time. So pi over 6 is going to be kind of one case, and 5 pi over 6 is going to be another case. So I can look at pi over 6, and if I add 2 pi, I can write that as pi over 6 plus 12 pi over 6. And that would get me 13 pi over 6. And because, so first, how would we get there? So to get to 13 pi over 6, we'd have to go all the way around. We'd pass pi over 6 on the first, kind of trip around, and then we'd land on it. So pi over 6 is one way to express this angle, but I could also call it 13 pi over 6. So 13 pi over 6 must also be a solution to this equation. And in fact, every jump by 2 pi, okay, is going to give us a coterminal angle and thus another solution of this equation. So how can I express that? Well, I'm going to write that like this. So theta is going to be pi over 6 plus 2 pi, but any jump of 2 pi, right? So what's to stop us from going twice around and then landing, right? And then having another angle there. And what's to stop us from going backwards, right? Or backwards around and then hitting it, okay? So there's lots of coterminal angles, and we just kind of need to know what that jump is. So the pi over 6 is our start, and our jump is 2 pi. And I can go as many 2 pi's as I need to in either direction. So I'm going to call this pi over 6 plus 2 pi k, and the k is going to be the number of times around, and positive k's will send me just kind of in that regular standard direction. And then a negative k will send me in that negative direction, okay? So k can only be integer values, like whole numbers, right? Because I can only do whole jumps of 2 pi. I have to make it all the way around. So I can't have k, say, be a half and then only do a jump of pi and then say like land down here where there's no solution. So what we do is we write k has to be an element of the set of the integers. Now this is getting a little extra mathy here, but all this is saying is k belongs to this set or is an element of this set, and then the set is here, and then this is just shorthand for the set of integers. So we could try that out, but again, k is just kind of how many jumps of 2 pi we are doing, and then the sign of k tells us that direction. We can do the same thing for 5 pi over 6. Now, can I include that 5 pi over 6 somehow in this jump? No, because the jump from pi over 6 to 5 pi over 6 and the jump from 5 pi over 6 back to pi over 6, they're not the same. They're not like that same opening, and so that's going to make it tricky. So we just do 5 pi over 6 just gets its own. So it's 5 pi over 6 plus 2 pi k. And again, k is just an element of the integers. So how would I write that in set notation? I'm going to write in my curly bracket and I say all theta such that. So what you're saying is all angles that follow or that satisfy the following condition. So you're saying all angles such that theta is what? Well, theta is pi over 6 plus 2 pi k, where k is an integer, or 5 pi over 6 plus 2 pi k. And since you've already defined k over here, well, you know what? Let's do it again. Because there might be some different condition here. So we'll just say where k is an integer. And then this says that as long as theta satisfies either this condition or this condition, that it will be a solution to that equation. All right, let's try another one. Find all solutions to 2 cosine theta equals root 3. Well, first we have to manipulate this to get it to isolate the cosine theta. which is root 3 over 2. And we go to our unit circle and we say, what's going on with that? Where would cosine theta equal root 3 over 2? And I say, well, that happens at pi over 6, and then again, not till, again at 11 pi over 6. Oops. So when I'm looking here, I notice that the jump, say, from pi over 6 to 11 pi over 6, and then the jump from pi over 6 to pi over 6, these are definitely different size openings. So I have to list the solutions separately. So one will be, theta can be pi over 6 plus 2 pi k. And again, the period for cosine is 2 pi, right? So I know that if I go 2 pi again, I'm going to land back on a coterminal angle that will satisfy this equation. Okay, so k has to be an integer, and then theta is 11 pi over 6 plus 2 pi k, where k is an integer. Okay, and so for my solution set, I'll just say theta is pi over 6 plus 2 pi k, and I could say, or theta is 11 pi over 6 plus 2 pi k. And at the end, I'll just say where k has to be an integer. And that can just satisfy both of these in terms of saying, what condition k has to meet there.